All right, I am online. I have 0 viewers. Yay! This is a. Wait, is that an ad? I hate Twitch ads. All right. Let's see. This will be interesting because it doesn't seem to have included the relevant source code. So I guess I can open it in the terminal here, or just look at the ASM. Because really, do you need anything else? But okay, yeah, this instruction stream is really cool. Let's see, where were we? Dark theme once again. All right, all right. This is probably not going to work on Pernosco, but sure. The people meaning one person. Okay, great. Okay, so if table handle miss, here, I guess. Yeah, let's go. Here we go. Now we get back to the JIT code, I guess. Wait, where are we? Oh, this is Pernosco doing stack traces by its own interesting methods. Huh. Is there a disassembly window or it's just this? Yeah, I think it's just this. Oh, there we go. Where the hell am I? Okay, this is useful. I'm in entry.s. Huh. Pronouncer seems a little bit confused right about now. Wait, okay, so we can jump back to... This is definitely being useless right about now. No source, please. Can we open S files? Apparently not. All right. I don't think we need this data flow right now. We should get a notebook. They're useful. Don't think we need std out. The plan for today is to fix this bug with where anything that creates threads hits page faults. and then I don't know, see if Docker works. But let's see here. Okay, we should put it here. Oh, and also use this as an excuse to play around with Pronosco. Or maybe it fits better over here. Yeah, whatever. I mean, we don't really need std out now. New Mac to win? No. Actually, I don't know. Maybe next year. Why do you think I need a new Mac? Ah, yes, 5300 RPM. Yeah, I mean OBS is a bit of a thing. It's just a little bit of a thing. It's all right, man. It's completely usable and everything. It's not thermal throttling. Somehow. I don't know how. Anyway, where was I? Oh yeah, TLB handle miss. We need to sort of step out of this. Time for sleuth. I approve. Okay, so we got a TLB handle miss. Interesting. Pronosco just doesn't have this source available to it. I don't know why. This might be a bug. Where can I contact them? Yeah, I'll do that later. Whatever. Okay, so we can go past these instructions that are like we have to what the hell is this? Where am I? Where am I right now? Handle miss load 32 mem. See, I want these in the trace, but not to be. Okay. Yeah, I just have to click stuff and then sort of look to see what it looks like. I think this is like prepare for reading. I'm gonna have to get good at reading assembler. Wait, okay, so you know what we should be doing is TLB handle miss. Here we are in something with source code. Let's find this. Let's get the source window up, right? Header is 16, right? So we should have data flow for that. Can we do that? There we go. How did it become 16? Well, it came from ESI. Why is this so useless? Oh, there we go. Okay. How did this 10 get here? I mean, it came from R13 somewhere. Is there like a registers window? Yeah. Wait, okay, so this point, R13 came from what? Oh, it's just the function names that are completely bogus. All right, it's good to know. Good to know. These all should probably go over here. Actually, to answer the question where the fuck I am, wait, so this is actually step to interrupt. Where? 18AF. Wait, this is a this is a lie. This is not where the IP actually is. Okay, that sure. Okay, where's the? Tell me more about where the IP is. Oh my God, why is that so hard to show me? Yeah, I'm probably gonna want to send this to the Pronosco guy. Be like, the the IP value is bogus, or like yeah yeah. There's probably some bugs going on here, but you know that's why it's free for the first few times. Um, let's see. Okay, we are actually here. Okay, this actually matches up. Um, Gadget addr reg BP. Okay, this is reasonable. This data flow makes sense. Can we look at BP here? BP is C. Okay, how did that become C? Store 32 reg BP. Okay, that's useful. You can do that. All right. Let's set it back to kernel school. Oop, no quotes, please. All right, so we're in gadget store 32 reg bip. Now, where did that come from? Oh, this is actually useless. What I really this is not showing the history of the value C. This is showing me the history of RBP as it was before this instruction. When I really want the history of R10, which became C here apparently. Oh, right there, of course. Okay. Okay, this loaded from memory. Wait, is this forward-looking? Maybe. Oh no, this is just completely useless. All right, that's good to know. That's good to know. We need the history of this thingy right now. What's R13 right now? This is a pointer, so no. Okay. Hello, Makanido. I'm trying to debug why, whenever anything starts up with threads, it crashes. Like these crashes here. Yeah, this press release contains forward-looking statements within the meaning of the Private Securities Litigation Reform Act of 1995. Good to know. Good to know. But right now I'm trying to trace this, like the crash is like a crash on this very low pointer value. So I'm trying to trace back why it is that value. It like added 4 to 12, getting 16, which is definitely not a valid pointer. Now, what are valid expressions? Can I? So apparently, I can access registers. Can I use pointers? Oh, no type checking. What? What do you mean? Okay, *0 fails to evaluate, of course. Let's try some other instance of pointer if there's no type checking, like, wait. This is a valid pointer. What is wrong? Can it be like star that fails to evaluate? Star. What? This is a valid pointer for sure. Now, can we dereference it? No. Oh, we got a song request. What's this? Alright, let's do it. You won't be able to hear because I don't have like the background audio thing set up, but I think that's for the best. No, it is not some whale thing. You know what I should do is add the Nightbot Auto DJ as an OBS source. I mean, it's probably not that hard. Like if I browser DJ, you can go to Nightbot. Right, so this page, yeah, but then I have no way to control it. Never mind. Just don't get me DMCA'd, okay? Yeah, the DMCA trolls have come after Twitch now in addition to YouTube, so it's good to be careful. All right. Oh, someone followed me. Garepa, thank you for following. I now have something set up so it makes a noise when this happens. Oh, another song request? Okay. No. Yeah, I worry about DMCA trolling. Let's see. I was gonna like actually work on something, but yeah, this memory location, what is it doing? What does it mean? You know what I think? Here's what we'll do. We'll set a watch point and reverse continue. There we go. It's not great, but it works. Okay, R10D. What's the data flow to R10D? Here. I should check, where are we? I guess we're around there. Push racks. Well, okay, the previous instruction is, let's go back a bit. Push 1C RBP. Right, okay, this instruction we're on right now is push this memory location onto the stack. Huh. Really? I'm confused by this. Wait, what's our IP? I don't think this is where we are. Okay. Yeah, I need to report this particular bit of pronosco brokenness once we make it through. But okay, we are in gadget push, and this instruction is, wait a sec, where were we? This point here, well, before that, huh. Wait, so, okay, sorry, what are we doing here? What is our IP here? This is load reg A, for some reason. Why A? Wait a second, I might be decoding this wrong considering the architecture. Like, let's try this again. But examine it not as instructions, but as bytes. And put that into some disassembler. Okay, does this make any sense? All right, I think let me try disas. This one includes the hex bytes, so I guess you can see them. Disas are. Can I say? Hmm. Oh, this is getting parsed wrong. I need to take out all these zeros. Okay, push AX. Move AL 78. Okay. Wait a sec. Why did I think this was pushing a memory location? I don't know. Okay, so we're pushing RIX, and at this point, RIX is C. Okay, let's trace that back. We pushed it, and then later on, read it off the stack, I guess. So if we can trace that back, how did that get to be that? Where are we? You know, that's bizarre. Why is RIP completely different from RIP in this registers window completely different from in the debugger? I don't know. Okay, store A. This is a store some value in A. What's this? Can we find out where we are? We're in BIP. Okay, we can dump our 9. This is our probable location. The last one we poked at was pretty close. Okay, so we're just here. Push 1C RBP. Wait, that is pushing a memory location. All right. Can we go back a little bit? Yeah. Okay. So shift EAX right by 3. Can we go back a little to like that point? Like, okay, what's this gadget here at this time? Load 32 reg A. But okay, so here we're loading A, and I guess, wait, what's going to happen to it? We're gonna load A, then it's gonna get shifted right by 3, So dividing by 8, meaning, R10D got shifted by 3. It used to be 63. Here we are. Okay, R10. Actually, no, we should trace AX from this point. How did that get to be what it is? Ooh, this is intriguing, at least. AX came from R10. What got shown? Okay, store 16. Why can't I scroll? I swear I'm scrolling. How about now? Load GS, store A. What is this? Okay, you know what? I forgot what load 16 GS does. We're looking for the thing at offset OX198, which is 408, which is word TGS. Okay, this is the actual value of GS then. And why are we then using it as a pointer? Okay, so to be clear, this is OpenRC that we're looking at, and I don't know what our IP is right now. Hope it might be in libc. I mean, this is going to be pretty easy to find out. Here it is. Boy, I wish we could dump out like the procpid maps of. Can we like dump out VMAs in the kernel easily? What I want to do is like cat procpid something, but might not be the easiest thing. Boy, I wish I could just let me dump out. Let me do like a 256 byte disassembly here. Hopefully that'll catch everything I need. So the GS thing happens at 279. No, 790E. 9E. Here it is. This is I guess, different. I guess this is encoded. This means something different in x64. XC config's done. Congratulations. Now you can write code. What's yeah, let's take a look at this. Okay, in x86, that is actually pushing the literal 51. So what the hell? Oh, it's huh. Huh. Okay, what? You know what? Let's take this and put this in the notepad or something. Can you do that? Maybe you can do that. Yeah, that seems to work. It's very small, though. I think we need to expand it a bit. Also, this really is not doing much good. Source view. Okay. Here's our disassembly of whatever bizarre thing is happening. Where were we when we were? Okay, this must be the GS thing. Huh. Okay, it's 99. I don't know why it's 99. Wait a second. I had a question of where are we right now in the instruction stream. Let's dump this thing a bit. Actually, you know what we can do is go like this. Star at 10. And we should treat these as void stars. Yes, okay, this is what I like to see. This is effectively like a IR dump. This 7A3 thing is because we are at IP 7A3. Here we go. Oops. Okay, I sort of didn't expect that. I didn't really want to seek, but whatever. Maybe I should have used Vim. But okay, here we are. Move GSAX. Push whatever the fuck this is. Shift X right by 3. Push this, do whatever the fuck. At some point we make a system call. And the seg fault happens in the lead up to the system call. I forget actually exactly where this is. Oh, the seg fault must be, yeah, isn't this the seg fault? Yeah, this is the seg fault. Is it? I forgot. This is actually probably really far removed from the seg fault. I mean, it's easy to go look at the std out. Let's see, okay. The IP is, yeah, completely different. 555, yeah, the seg file happens in a completely different place. Okay, but here, what can we see? What number system call is this? OX78, which is 120, which is clone. Okay. Interesting. So let me guess. Let me guess this is the which argument does this whole structure go to? RBP. Okay, I assume, okay, RBP is somewhere on the stack. The arguments are going to be A, B, C, D, DI, or DI, SI. Oh, okay. SI is pointing at the stack, meaning it's like, which argument is that? Psi. Okay. Argument 0, 1, 2, 3. Or I guess the fourth argument. And what's the fourth argument to clone? IA32. Sys IA32.c. 1, 2, 3, 4. It's TLS val. And this is a pointer to a user desk. Right, okay. And this GS thing, which is 99 for no apparent reason, I set it to, actually, yeah, it's, I don't know. This makes a little bit of sense, but not a whole lot. Great. So, what I guess then the question is, why do we we can trace directly from this shifted AX value to the bad pointer dereference, right? So what does AX do here? It gets pushed. It gets shifted right. Here's where we move it from GS. It's OX63. If you shift it by 3, you get 12, which is the same as this magic number here. Probably not, probably Not a coincidence there. Let's look at getting user desk. The first 4 bytes are the entry number. That explains that. Base adder limit, I assume we're trying to pass these in as other parameters here. We should take a look at the clone call mostly creates a thread. Oh, is this it? Yep, this is it. Well, okay, it goes on a little more, but yeah, that appears to be it. Thanks, Rich Felker, for making this as readable as possible. Who calls this? I don't even know what parameters this is supposed to take. Uh, I, I guess this? Yeah, that would make sense. In func void star, stack, flag, arg, and var args. Is there like a previous version that was more legible? Or like what even changed here? LMAO. There's no hope. But okay. Sure, okay. I mean, the S-trace of this is probably the most useful thing to look at. Clone. This is what it ends up producing, I think. We have TLS pointing to this pile. Entry number is... Okay, how does it define the base adder here? Right? The goal of this is for the new thread to have its GS TLS pointer thing pointing to this. The same segment number is used in all threads for the hell of it, and but the base is different, and this is always the base. So why that? Remember, SI is the argument. Here it is, ESP SI. Push EBP, ESP, EBP. To remember the stack goes down. Okay, so SP, so like it's pushing pieces of the structure onto the stack in reverse order. or something. Like, okay, if we push OX51, what does that even do? Pretty sure this is pushing 32 bits. Like, all pushes are 32 bits in 32-bit mode. I mean, I can guess that it's like, well, these 4 bits. Well, this is 1, 2, 3, 4, 5, 6, 7 bits. So this is a byte put together. And then you would eat into, like, actually, I have no idea how the structure is padded. You know, let's print the layout. Three bytes of padding. So, right, so the last push 51 sets the values for all these flags. Yep, we are building the structure from back to front. Then, we push whatever this is, and that sets the value for the limit. Yes, that makes sense. Then EAX, which came from GS. I don't know why these are ordered this way. Like I would put this instruction before this instruction. But okay, we shift GS by 3, and okay, what the fuck does that even do? Oh, is that supposed to be an argument to the function? Must be. But okay, so at this point, EBP points at the return address. You add 4, you'll get the first argument. You add 4, you'll get the next argument. But we've added quite a few to get to this argument. Well, it's prototyped apparently as having, wait, 7 arguments? Which argument do you get if you have 28? You just divide that by 7, right? Yeah, the 4th argument. No. You divide it by 4 and you get the 7th argument. So this is a CTID. Should be, at least. But why? We don't want to. Why do we want to put that in the struct? If we push it here, where would it go? It would go. Oh, it would go over the base adder. But wouldn't you want this, not this? Maybe my math is off. Maybe if you add 4, you get the return address. I can never remember how these things work. And then if you add 24 past that, you get the 6th argument, which would be TLS. In this case, like an actual TLS pointer instead of. Wait, what is going on here? Okay, sure. Where's the thing in like pthread that calls this? That's what I really want. Here, okay. 1, 2, 3, 4, 5, 6, 7. Okay, that seems about right. We would want this argument. Okay. That goes in the base, and then finally, the entry number is GS. It just comes out of GS. Whew! Breathe. Okay, then I'm starting to think that the follow-up usage of this was actually stack garbage. Can we set that watch point again? Okay, here we go. Wait, we're still in about the same place. Okay. Yeah, I don't think we've really moved. Crap, I lost my place. there's some place after this where it uses this, where like from the value at this, from this value it produces a set, it adds 4 to get an address, and thus you get a seg fault. So where's that? Can we do a read watch point or something like that? Like, yeah, I wish I'd saved my place, but who, oh well. I could try a read watch point. I think that would be rwat. Nope. Okay then. Yeah. All right. So with this big dump of assembly, we've saved our place here, so we can just go. We can try just journeying on. Actually, what's a good way to find this? Can we jump to the next execution of? Let's go through executions of TLB handle miss. Yeah. Yes. That was so much easier than I thought it would be. Now go back here, see where are we at. Okay, let's save our place. We are at handle read miss. Let's go back a bit. Gadget load 32mem. Oops, I didn't want this to be in a binary. There we go. Now here we are. Can we go and disassemble this chunk of code like this? And we can drop this in the notebook as well. Like there, why not? Okay, where the fuck I am? E7 and 8. Here we go. So this is the point on RBP where it blew up. We should trace back this RBP value to here. We're now at 5C. Roundabouts. Like, oops. But yeah, but we're about there. Okay. What is this function we're in? Call, add, push, mov, push, sub, mov, lead, mov, zor, mov, reps, dos, mov, sub, mov, push, call. This could be memset. Basing this off of the reps, dos. I mean, this being muscle, if I search for memset, I will probably find Yep, an assembler file with yeah, no, this isn't it. Uh, this is very much not complicated enough to be a memset. Um, okay, but we should be looking at this mov for RBP. Oh wait, no, that's where it blew up. We have to go up a little bit to find out how RBP got there. RBP came from, well, EBP came from 140 on RSP. Why is it 12? Who knows? What is ish and doesn't have anything to do with Gentoo? Ish is this thing and doesn't really have anything to do with Gentoo now. Why do you ask? Yeah, let's trace. Let's go back a bit more. Like, can we go back to whatchamacallit, to before this was called. Yeah, it's a shell for iOS. I'm the way it worked before was is like I would like rewrite all the everything in Linux basically for iOS, and now I'm gonna this is not the same fate as WSL1, so now I'm trying to actually use Linux, and right now I'm trying to figure out why threads don't work in this setup, but most other things seem to. Um, okay, so let's go back a bit. Pick this randomly. Where are we? I am on Mac, yes. Yeah, it's nice. 558 EE53 E53. So we've made it here. Got to go up a little more, I think. Where are we now? 4D. Okay, a little more. There we go. And okay, at this point we jump out and we jump out of the JIT entirely, or like the interpreter loop. Go through all this interrupt crap. I think I'm going to need the source code window to get out of it. Okay, I had previously traced the um, this this thing that says BP to be pulling it off of SP, and I traced that back that memory location of SP to be a temporary stack variable used by this clone thingy. Specifically this. But then I have to know why on earth is it now reusing this, what is effectively stat garbage? So, but okay. Yeah, so we're here right now. Can we get back a bit? Ooh, let's do that and print IP. Ooh, can I format as hex? Don't think so. Oh well, but at least I can see these numbers. Um, God damn it, why can't I? Oh well, I guess that could become a feature request. But anyway, does this look anything like what we've just been executing? No. Okay. That doesn't make sense. What about this? Okay. Ah, there we go. Okay, so if we go back here, it doesn't move much. And if we go back here, this is, I guess, where we came from. BB1. Can we get some dump of this? Hmm? Okay, I'm confused as how this really helps. But okay, you know what? Let's do. Oops, I didn't mean to fold that. Let's do this, and then step back a bit. We're just gonna scroll through time a bit, I guess. Wait, why are we coming out again? Oh wait, no, we came out of this getting a seg fault. So we need to go actually step back to the previous execution, right? There we go. Now we can reverse step. Why do we need to reverse step? I can just scroll through the instructions executed. And now we find ourselves in something. BB1. Fun. All right. Yeah, interesting. We had a very short basic block here. Oh man, I wish I could like disassemble this, like actually match this up to. Okay, now here's what we're doing. Let's go pull out the muscle and try and match this up. While I copy files out, I guess hostfs. Yeah, so that should give us the right version of muscle. And we can try out objdump. Objdump. I wonder if this has a certain number of symbols. That'll be invaluable. Again, where are we? BB1. BB1 8B0424. That's not a thing. Okay. It must not be muscle then. It must be OpenRC. So we can copy that out too. Wait, is it OpenRC? Well, the process is named OpenRC. I might have an strace. OpenRC. Yeah, if I search, I might be able to find an strace of this. Yes, okay, here we are. Yeah, this is OpenRC itself trying to make a new thread. So this is the right binary to be pulling out. Okay, objdump OpenRC. Nope. Okay, wait, I'm doing it wrong. This should be BB1, not BB8. And there it is. Okay. Yeah. This is not Star Wars. But it's too close. Okay, where were okay, so what's going on is this called into the BB1 thing. So we should look up what this E43 thing is. E43. E8. Could be one of many things. 69, nice. 70. That must be it. Okay, vfork. Huh. OpenRC is trying to spawn something using vfork. That's interesting. Then what the fuck? Does this not actually have anything to do with threads after all? Huh. Let's have a peek at vfork here. I've yet to find any debugging technique more powerful than reading the source code. Wait a second, is this... Should I be reading this? Oh wait, no, this isn't actually vfork. Vfork ends here. Pop dx be int push push call pop. Yep, that's a vfork. And we're looking at a function that ended up right after vfork in the binary. So it's internal. Let's go back to Pronosco and find who called it. There we go. Wait, no, we wanted to step into this. Okay, forward. Wait, no, never mind. We wanted to go backwards. Never mind. So we want to go from this, forwards, and then backwards. And we are here, apparently. 77. Just a little bit of disassembly. Okay, that's 77 FF. Okay, what the fuck is this? Well, I mean, it's got inc ex followed by int x80, so it has to be some assembler written by Rich Felker, which means we can just search for inc ex. It's not math. Okay, it's this. Oh, this is a thread startup function. Okay. I'm pretty sure that it is threads after all. Okay. And the thread startup function is either start C11 or start. It's probably just start. Whatever that is. Here it is. Void star P. Okay. Where is it again? Right after vfork? Yes, here we are. does this make sense for this to match up with this? Like, okay. Or am I looking at the wrong thing? I should be making more notes. Okay, that's clone, and right, okay. I remember this. It's this, the instruction right after the reps dose that explodes. And comes from here. So we call this BB1 thing. Here we go. BB1 comes back with, oh my god, this is probably a thunk thing. Yeah, it's the only thing it could be. Right, so this is the pick thunk. Then we add whatever this magic number is to AX. Right? Push RPP, magic number to CX, DISIBX, subtract from SP, and then, okay, it's probably, with this, it's probably trying to pick an argument, a function argument or something. Which one would that be? Let's see. We're taking off 1C off the stack frame. We've pushed 4 things, so that would be 130, 134, 138, 130C. Well, okay, if we subtract these can cancel each other out, so it's like 4. There's a difference of hex 1, 4 between these. This cancels out 4, so hex 10, hex C, hex 8, hex 4. So it's as if you're, going to hex 4 at this point. But yeah, at that point. And if you did that, I think you'd get the first argument. Yes, you would get the first argument. So here at this point, BP is supposed to be the start arms pointer, but it's not. Why not? This means we have a problem, like starting the thread with the right IP value or something. Or the right stack pointer, maybe. So where are we right now? We are yeah, can we give this a note so I don't lose my place? But I actually have no idea what my place is right now. 77. Oh! Point in clone that calls the start function. And what if the argument it's trying to pass? What the fuck and why does this make sense? I guess, Rich Felker be like that. Like what? I don't get it. Like, wait, okay. So this is calling the function, the thread startup function. If this function ever returns anything, you're going. Oh, you're gonna take 0 and you're gonna add 1 to it, and then because this is shorter than calling, then just move 1 to EAX, because you want to call exit, which is syscall number 1. Okay. As for arguments, you pass an argument by pushing it right before the call instruction, right? What is the stack pointer pointing to at this point? The stack pointer just has never moved since the start of the function. Meaning, wait, BP for some reason, how does BP contain the startup function? Oh, because of this. Oh, because the syscall has so many arguments that one of them is passed in BP. That makes sense. Then it goes to X, AP, and right, argument. How does the argument make it in here? I mean, it's just going to go for ESP plus 4, meaning, well, since ESP plus 0 is the return address, ESP plus 4 will be whatever's top of stack at this moment. So basically, whatever happened with the last push instruction. Which happens was push. Okay, what the fuck? This feels like one of those things that could have never worked in the first place. The last thing we pushed is like exactly the thing we see it segfaulting on, which is the TLS value. Is there something I don't know about clone? Excellent image results, but no. Oh, this is, what's the prototype of the raw system call? It's probably different depending on the arch. Notes, where's notes? Oh yeah, it is different depending on the arch. Let's take I3 to 6. This one. Flags, stack, parent TID, child TID. We're probably ignoring the stack argument. I feel dumb, but yeah, that's not uncommon. Let's see, sysIA32 is what's doing it. Clone flags, new SP. Huh. Oh, is it this? USP? Alright, this is easy to check with Pronosco. Go find calls to copy thread TLS. And yes, it actually puts a value in USP. Well, okay, it's a user space pointer, but yeah, that must be it. But then you notice a lot of times it puts 0 in USP, and I wonder if that means you're supposed to ignore it. But anyway, Pronosco does make it extremely convenient to check to figure that out. Like, we don't need the disassembly anymore. Let's get the source. Because now we actually have source for things. Copy thread TLS args stack. So arg stack is 0 sometimes. Actually, can we data flow this? Yeah. There we go. Sysfork leaves stack as 0. Yeah, I think that's just what you're supposed to do. Ignore it if it's 0. So if USP boom. Let's give it a shot. Nice. It worked. It's slower than I would like, but, you know, that's just how it goes. Can we git clone? Okay, this is still broken, but this is an improvement. Oh, get random. That's unexpected. Huh. Wait for random bytes. Why do we have to wait for random bytes? I thought there was like an unlimited number of random bytes available. Yeah, so that's the next bug we have to fix is dev random. Well, yeah, I call that a success. Let's make a git commit. It's gonna be a very short git commit. That. Anything else? Nope, that's it. And I think it's gonna amend this. Yeah. And now we need a better name. Oops, I didn't want to commit that. I should yeah, the whole thing about just fucking creative thread for me, I should either commit it or delete it, like, real soon now, you know? Okay, but now we have TLS working. Get threads working. Sounds about right. OpenRC is still slow, but that's an emulate problem. Sorry for vacuuming. Do we need to say anything else in this commit? Nope. All right, that's the commit. Okay, now let's figure out what the fuck went wrong with random. Why the noise? My mom is vacuuming. My apologies. Maybe I should. Aren't there some like machine learning based noise reduction things that would like ostensibly help here? That might be cool. It would actually work. What happened to me vacuuming? I'm not. I guess not today. That's better. Right, so randomness. What is up with randomness? goes to wait for random bytes. Darts to wait for There's probably a much simpler repro case, which is just cat dev random. Oh wait, no, that's doing something. What about you random? That's also doing something. Okay, no. Is the difference that it's doing the system call, or? In that case, let's write a test program. Okay, what's it doing? This is not encouraging. An encouraging sign of progress. Ugh. I remember seeing this before, and I don't really know what it means. It also means I can't press any keys. Yeah, this just sucks. Like, that much is clear. I think I have to kill it now, actually. Oh, this time it works, great. So it's like sporadically, it just starts thrashing the hell out of it. But not this time. This time it works fine. We'll figure it out someday. I mean, we gotta figure it out to shift, otherwise things will just hang randomly, and that's bad. Ooh, I'm gonna need. Ugh. I can't press Control U, I guess. Alright, let me just call it, give it like a nice buffer, and print the return value. This is probably just pruned random. We shouldn't use non-blocked because, you know, blocked, that's no good. Yeah, we need to install a little bit more. It's gonna thrash. No, okay. performance is not perfect because of the suboptimal way of disabling interrupts that I've implemented, but you know, I'll fix it one day. Okay, we should be able to compile it now. Just kidding. All right, we fell down the rabbit hole a little deeper. What the fuck is happening here? Is it vfork? Can we not vfork? Yeah. Oh, I should be doing strace f. Huh. So it's okay. OBS global hotkeys no longer work, and I didn't do anything to cause that. So you know, whatever. Wait, okay. So which process died? Okay, 146 is the new process, and is apparently also the process that printed, "Hey, I crashed." Wait, where's the log about the page fault? Here it is. Okay, so it caught its own seg fault and printed, "Hey, I died." Right, okay, that's not good. And a page fault on the instruction pointer. All right, what do we do? What do we do with this? I don't know that a stack dump would be that useful. Actually, do I still have the ability to call dump stack? I'm reaching for my old tools. Wait, you know what would be a better idea is if we go one step deeper down the rabbit hole and GDB GCC. Because GDB is an objectively superior tool to all the crazy hacks I've been doing previously, and now this is within reach. We just gotta implement a bunch more architecture-specific ptrace operations. Okay, JDB doesn't work. Presumably for the exact same reason. Oh my god. Alright, never mind, that's not gonna help at all. But yeah, this looks like substantially the exact same bug. It doesn't even fork. Is this just some shit with threads? Oh no, there aren't even any threads going on. Oh nice, we have ASLR enabled. That's kind of cool. But can we not? How do I turn that off? It's... Okay, that doesn't help me. That does not help me. Guess not. Yeah, that means I'm really gonna want the... I should attack GDB first, because, you know, if I fix that, then everything else is easy. Dump stack. I forget where the code for this is. Oh, it's here. Okay. This worked with a sort of loop. Right, I'm gonna do this in the debugger. If I break on, where is it, ish process, line 110, if I remember right. Yes. If we can handle the page fault, that takes many more seconds than I would like. Okay, but then what you do is GDB. That's it. SP. Here's our stack, and then we can just dump it. Like, maybe I should turn off ASLR. That seems too hard. Okay, but now we can at least dump the stack, right? Okay, but of course, that can be dumped. Wait, how do I format it as like a series of? How do I group it by 4? Is it like x/w? What is going on? I have ascended and simultaneously descended to a new bug, in which I try to run GCC and it crashes, and I try to run GDB to debug GCC and it crashes too. And strace wasn't very helpful. Actually, let me take another look. Yeah, very little happened. We set thread area, we set tit address, burk, and page fault. So, yeah, it's a bit of a mystery what's going on here. Oh, it's a fault on the IP. So, let me go disassemble this thing, which is presumably the return address. Wait, can I get the bytes out? Help this as mixed line frame bytes. Yes, bytes. There we go. We want 8B44. Not there. Just kidding. Not there. Yeah, that matches up. Might be just either I'm looking at the wrong version, or I didn't think GCC had a lot of, or GDB had a lot of dependencies. I should look. Maybe I should look closer. Yeah, let's go get these out. Mount. Where are these crashing? I am trying to find out. If I had GDB, I could just get a backtrace, but GDB itself is crashing. So, oh, actually, it has a bunch of dependencies. And these are where they load. At least if ASLR is disabled, I guess. I don't know. Maybe I can judge. Oh, I don't know if executable ASLR is enabled. Maybe it's just the stack. The stack is definitely randomized, though. I mean, well, if I look at this, where does that land? That lands inside muscle. Okay. Yeah, I must have been looking at the wrong version of muscle. Let's go dump this. Regrets. I should have opened this down here. Then I could cross-reference with the debugger. Yep, that's it. Okay, what is up, my dudes? This is a function called 2 times, well, it's called by this. It's quite fun to sort of try and guess where things are. Oh wait, no, I should look a little deeper at the stack. Okay, what's this? Let's go back to the debugger so we can keep dumping things. Okay, that looks like nothing useful. What's happening here? Is this not valid memory? Oh, it is. It just doesn't make sense. It's disassembly. Or that. Okay, we need to dump more stack. How about this? That probably points somewhere to that. Well, I mean, we were very recently new here, though. Yeah, this is in the same function. Can we go further back? All right, this should be valid. It's even further back in the binary. 370 D 6C. Interesting. A function that ends by calling exit. I mean, we can just search for calls to exit, I guess. What do you mean? Oh, one repository cloning. There we go. There we go. Regex, word boundary, length C. Okay, there are a bunch of functions that end with exit. That's not very useful. Who calls this one, though? No one? Okay. Shall we peek a bit further up the stack? 6.8. Okay, that's called to whatever. What the fuck is this? Oh, that's the thunk. Never mind. That's useless. Okay, so we shall go further up the stack. Where does the main executable get loaded? It doesn't show here. Well, okay, but it can only call things that are exported, so we should be able to go up the stack high enough and find something that is exported. But we aren't yet. That's the elf header of muscle. Let's go further. These look like strings. This is probably, I've probably gone all the way up the stack at this point. Like if I print these as characters of size 1, yeah, we see environment. So we've gone too far. We've jumped literally the entire stack at this point and are no closer to an answer. So I know that this is too high to wait. It could land in. I mean, it could land inside of a different. What are the bounds of muscle? Okay, it's quite large. It goes up to 55C. So this will land inside muscle, but I don't think inside the code segment. I mean, we can try it. Yeah, no. Anything less than 555E? Anywhere? 555E. And here's the bottom of the stack. All right. Shit. Interestingly, I don't think we got far out of libc startup. Okay, yeah, I guess let's look closer at what this calls. This calls this thing, whatever this is, which calls free at some point. That's useful to know, I guess. But then it calls this, which calls p for mutex lock and cond wait. Right, this is still useless. But then we call this. This is a popular function. Lord knows what this does. See, I suck at reversing. How about this? Okay, this is another one of those things. It does who knows what. Wait, maybe I can figure out what this does. Push B, move B, compare CB, jump equal here. I don't know. Maybe we can look for functions that end with free? I don't know. The sense of a calls are free and a store. Sure. Let's. I don't know what else to do, so let's search for calls to free. There are 112. Well, mentions of free. Dynlink calls free sometimes. I mean, just based on the part of the executable this could be part of dynamic linking. This could totally be part of dynamic linking. Like, how far have we gotten so far through dynamic linking? We loaded readline lib, zlib, and curses lib, python lib, expat libs, disables, plus lib, gcc. Actually, I think we got out of dynamic linking by this point, so not that. Oh, and the other constraint is this function is not exported. Who else calls it? It has one call, which is the function we want to know about. It's called by a function that ends in exit. How many functions are there that end in exit? Hopefully less than that. Yeah, there's actually less than that many. So it'll be like this and this and this. Well, what status? It comes as an argument. Oh, is this libc start main? Maybe. This isn't it. This could totally be it. Maybe. I don't know. Wait, no, that came from an argument. Well, okay, no. We have an indirect call followed immediately by an exit with the same status as the return value of the indirect call, meaning that it is actually probably that. Okay. Great, we're looking at libc start main, except... Oh, then this is libc start init. Gotcha. Then that is why we couldn't find anything exported. We went all the way to the top of the stack. So libc start init. That's why we see the call to free. But okay, hey, where's the... where was the seg fault again? Oh, is the seg fault on this indirect call, right? We must have done a disassembly and found this out. This being the return address, we disassemble around it, we find 12E, whatever, 8B, 44. Yeah, this, okay. Yeah, this is a little different. I don't know how we ended up at libc start main. Oh, that must have been because I started going up the stack. Okay. So this crashes on this indirect call right here. Okay. All right, we can go up the stack a little bit from libc start main. If I remember right, this is libc start main. This, or this. Yeah, this. I assume this would have been inside of libc start init, maybe? Do init fini? Oh, does it see a bad, like, init fini thingy? I assume we disassembled this at some point. Like, okay, that was nothing. Oh, yeah, we should look at this. What is this? O1D81. If we can figure out what this is, we're good. Who calls it? Two callers. Which one? Well, the return address is 374, so it must be this one. Yeah, this one. This one is the caller. And it is called by libc start main. So we're in libc start init. I think we call it the do init fini. This is probably do init fini. Right? Oh, this is libc start init, and therefore this must be do init fini. All right, here we are. Here's the big pile of pthread shit that I was looking at earlier. Yep, lots of pthread stuff going on here. Okay, can we go up a little bit and find, I guess this? No, that's not anything. Maybe this or this. Those could be something. I doubt it. All right, where's the indirect call? I mean, what we figured out so far is this is evidence. Well, this is nothing but evidence do init fini has previously run on this stack. Okay, now we see a bunch of stack 55A. I don't know if I've looked at this. Apparently not. But we don't randomize this, so that's good. Okay, that was nothing. This, therefore, is also nothing. And then this might be something? No. Okay, now we arrive at this thingy. Oh, this is part of the same function. Okay, then yeah. We are looking at a rogue member of the init array. Aren't there going to be more indirect calls, or is this the only one? No, there's one more. So this is the second one, whatever that means. Okay, so we support legacy init fini, I guess. What's the address? Page fault. 4852. 4850. It's always the same. Maybe it's forgetting to rebase it. I mean, we could test this theory by looking for offset 4850 in some binary, like 4850. This is not in muscle. We can look at JB. Okay, this is large. Very large. This is also not a thing here. Yeah, I don't know. Um, I'm gonna go do something else and refresh my brain. Thanks to everyone who was for some reason watching.